quality basics.
Thank you, Barry. Good morning, beautiful people of Indiana. Good morning. That makes me feel so good, guys. I get to travel the whole country, and I travel too much, so I get to be away from my wife and my kids too much, but it's worth it because my wife says this is a huge mission, and we're all excited about it. I'm telling you, I think we have just absolutely pierced into the heart of conventional agriculture through the soil health. There is going to be an incredible change to the whole country about sustainability. And I tell you, Ken, with some of the things you said today, I said, I think I'm going to just take him with me every time. So that it's nice when it comes from a farmer from NRCS in person, and they're going to throw rocks at me, but it's okay. But I think Ken said a lot of things that are true. It's about being sustainable. You know, the first chief, by the way, before I start talking here, how many here are NRCS employees for the training? Yes, beautiful. There's going to be a test. How many of our partners? Department of Agriculture? Environmental Management, thank you for coming. Fantastic. What? ISDA, thank you. District employees. Any landowners, farmers? Anybody farms on the side with their government job? Thank you. Okay, fantastic. I'm going to make sure I got everybody here, William. I got to make sure we...
University.
University. Oh my gosh, our university partners. Fantastic. Thank you for coming. And ARS? Anybody from ARS? Okay. Here's the thing. NRCS employees. Who was our first chief? Hugh, right? And where was he from? North Carolina, guess where I live? North Carolina. Here's the thing I'm bringing him out, mentioning him, folks, because of this. When you have this big thing going on in the country where our resource, our soil was hemorrhaging, he was there and started the agency. It was huge. Now, folks, it's much more than preventing the hemorrhaging. It's preventing the healing, getting the healing to happen. Soil health, this chief, Dave White, we're going to bring healing into the land to make it sustainable. Some of the information they did not know, we know. The science has been out there for a long, long time. It's been included. There's been soil ecologists, soil microbiologists that have known this. It's a living ecosystem. So what we're going to learn today is how to farm in nature's image, and it is a journey of understanding. I love this comment from Barry. It's a journey. It's a journey of understanding with our landowner and ourselves on how to emulate, how to mimic nature. That's what we're going to learn today. We're going to learn the biology part, the ecology part, the things that just tend to be, how would you say, ignored a little bit. So we're going to learn that. And we're going to start off with to me, the most powerful tool is the soil slate test. And I'm going to ask some of you guys from the back, the last two rows, come up. The last two rows, stand up. And we're going to move to the side. Everybody. And then this row is going to go over here. So yes, do you know that when they first started the Soil Erosion Bureau, they said that soils was an inexhaustible resource. That was the understanding when they first started NRCS. Come on, guys, over here a little bit more. We know that's not true. Come on, more. Don't. Oh, by the way, I want everybody to come on, guys, a little more closer. Come on. Come on, don't feel nervous. I don't bite. I did take a shower this morning. Come on. Come on, guys, get a little closer this way. Now, I think we can see everybody.
3 seats right here.
I'm gonna see 3 seats. You guys come over here, right here. Okay, everybody can see, right? Everybody has a visual. Michelle, you want to help me? Fantastic. Come on, Michelle. She's with FSA. Yeah, let's come on, get one of our partners to help us. Okay. To me, we'll go ahead and stand on this. Okay, what Michelle's going to do. Now, NRCS people, you need to learn how to do this. This is the most powerful visual indicator of soil health. It is called the slate test. There's a lot of research behind this test. Very complex test. It works on about 95 to 98% of our soils. Some soils it will not work because of the mineralogy. So we call it the slate test. I prefer calling it the soil stability test. It's simpler. Nobody knows what slate means. Okay? It just means it's falling apart. Now, what we're going to do, Michelle, is going to get these clods or aggregates or pads, and we're going to drop them into the water. A good, healthy soil will not fall apart when it goes into the water. These are just plain cylinders, graduated cylinders, with water. When you do this test, it's preferably that you do it when the soil is dry. Okay? And the way it's going to work is she's going to drop these clods, these aggregates, into the water, and the water's going to rush in to fill the pore spaces. There's a lot of millions of pore spaces in each clod or aggregate. Okay? Now, what you see here is several types of soils. The first two are from North Carolina, then we got one from Ohio, and the last two are from Indiana. And Barry will explain some of the management on this one. I'll explain the management on this one. This is 40-year no-till. It's a Cecil sandy clay loam, North Carolina. It's about 30 minutes from my house. It's got 2.75% organic matter. These two soils are a stone throw away from the lake at Reedsville. It's a water source, it's a drinking source for the town of Reedsville. This has 2.75% organic matter, has not used chemical fertilizer in 16 years. It has not used phosphorus in 9 years. It went from 5 herbicides down to 1 herbicide. This is the neighbor's soil. Same soils, look at the color. You see the color, Michelle, difference? Vegetable, never covered. This is covered all the time, 24/7. Living cover or a dead cover, but that soil is never bare. Okay? Now, you're going to hold those. This comes from the Ohio Research, how do you pronounce it? Coshocton conventional tillage. And this is Rodney's no-till, okay, that we collected yesterday. Long-term no-till.
History of cover crops.
History of cover crops. Well, actually, it's just a couple of years ago. It's right on this side, okay? Right where we're going to do the pit. And then this is Barry from where?
It's from Putnam County, but it's a very similar soil type to what we would have out here. It's a Reedsville soil.
Reedsville soil.
Silt loam, conventional tillage.
Okay. Now, let's go ahead and stand behind here, and you and I will get out of the way. I'll hold the little white thing here. Well, let's go ahead and get this first. So, okay, so what she's going to do, she's going to go ahead and sequentially drop the clods in. And we're going to see which one holds together. Ready? Go ahead. No-till, the conventional of North Carolina. Let's get the other one. Conventional Ohio. No-till, Indiana, and conventional Indiana. Now, why, class, oh, guess why you have name tags? I'm going to call on you. And I want you to feel comfortable. 7 years ago, I could not explain this, ladies and gentlemen. 7 years ago, I could not explain this. And I went to graduate school for soil science. Okay, so I want you to feel comfortable. So we're going to call on the class, and we're going to say, Evan, what in the world is going on with the conventional? As soon as we dropped it in, it started slaking very badly. Water rushes in to fill the pore spaces. The soil cannot hold itself, does not have the integrity. It starts falling apart. Pores collapse. fills with particles, and you have crusting. What's going on? The years of tillage is breaking it up. So how is that happening, Randy? What is going on? You're increasing biological, you're decreasing biological diversity because you're making it bacteria dominant, yes. But let's back up a little bit. Who makes the glues to hold this? Look at the no-till. Why is the biotic glues in the organic matter holding the glues, holding the particles together and keeping the pore space intact? What's going on? Who makes them, by the way, Gary? Soil organisms. Like which ones, Neil? He's going to, why did you call on me? Oh. Oh my goodness, fungi, as they go in there searching, they build this relationship. The root and the fungus build a relationship, says, hey, fungus says, you give me sugar, I will give you zinc, I will give you phosphorus, I will give you all these some of these trace minerals, and I will help you survive the drought. And when I'm looking in through the soil and going through, I exude what kind of glue? James? What's the glue that was discovered by Dr. Sarah Wright? 1995, ARS. Anybody know? Oh, beautiful, you're giving me a rash. Of excitement, you guys are awesome. Glomalin or glomalian, depends where you're from. Okay, so these glues are present, these biotic cementing agents, the organic matter. Who else makes these glues? Matt? It's a good question. I didn't know that question either years ago. How about you, young lady? What else? Earthworms. Oh my goodness, earthworms. As they're going and they're eating and they're pooping, they're gluing the particles together. They're beautiful. Aren't earthworms cool? Earthworms. Who else? How do you pronounce your name? Aryarchaleta. Oh, that's beautiful. And at least, what else? We talk earthworms, fungus. What else? Insects, the arthropods on the top, the grinders, the mixers, they're part of the system. What else? Saprophytic fungus, right? We're missing one. Oh, he's hiding. Evan, you thought you were going to hide, didn't you? Nematodes, they're predators, they help, they're part of that system. But I was thinking of something else. We're forgetting something that's very powerful. I call it it can shift the whole soil ecosystem. What do you think it is, William? We mentioned, we're forgetting something that we see every day on top of the surface. And it captures solar energy. And it's green. I'll give you a lot of hints of that. The plants. Man, that was awesome, William. Right there, he's going down that road, wasn't he? So it's the plants, the soil organisms, all this create this living soil ecosystem. I never knew that our soil biology is what gives us structure and keeps the pore space open. Now, let's pick on this side. Oh, you thought we were going to get away from you, right? Okay, now, what happened to the biotic glues and what happened to the organic matter?
No-till, stay together.
You tilled? So what happened? What happened when you tilled? Oh, by the way, I think tillage is the most destructive thing we do in agriculture. The most destructive thing. What does it do? What does it do to the whole, the soil ecosystem? Well, you're going. Tell me what's going on.
Well, it mixes all the aggregates and stuff, creates oxygen and changes the fungus and stuff in there. And
did you hear him when he's saying, guys? When you till, you break the aggregate, you sever the hyphae, you smash it, you wake up these bacteria called copotrophic bacteria. Copotrophic bacteria or zygomycogonous bacteria. They're in the nature and properties of soils. You should have that book. It stirs them up. They have an incredible metabolic rate. Remember, Andrew, when you were a teenager, you eat a lot? These bacteria have a horrific metabolic rate, and they start eating the glues and the organic matter. They give off CO2, they die, and what do they release when they die, Troy? They call mineralization. What do they do when they die? They release what? Nitrogen. But so they release it all in a flush, eat all the glues. Oh, guess what else you did? And I did this on my own farm. You bring weed seeds to the surface. And the weeds say thank you. And some weeds love nitrate predominantly. You just stimulated secondary succession in one event. You smash open the aggregate. You sever the hyphae. It's like you burned your house down. It's like, well, the farmers love it because some farmers get a flush of nitrogen and their crops get greener. But you burned your house down to warm up a hot dog. You destroyed the whole ecosystem, that organization. You destroyed it, one event. So let's get it straight. So you till, you bring oxygen into the system, you wake up the copotrophic bacteria. They start eating the glues and the organic matter. They die and release nitrogen. The weeds get a flush of nitrate. You bring the scabs, the healers, to the land. They're the healers. Weeds are the healers of the land. You bring the scabs to the surface. They say, thank you very much. And you just brought more weeds to the top of the surface in all one event. I wish I would have known that when I was farming. I would have not worked so hard. Okay, now we're not finished. Now, how do you say that again? Elias, come up here and you're going to still help. No, you can't hide, Michelle. Come up here, Michelle. Okay, we're going to do the infiltration. So you're saying, okay, if the pore collapses, big deal. Get on the other side, Elias. Okay, so if the pore collapses, I don't know about you folks, but we've had drought. I've been in North Carolina 7 years. 5 out of the 7 years we've had drought. You guys are experiencing our drought. Ray Steyer's grew silage corn with less than 11 inches of rain. Why? Because his soil is healthy. It's resilient. This is the best crop insurance you can ever have. And guess what? You don't have to fill up a form. Let's go this way. Now, we're ready? Now, let's take it. I don't know about you, but I want to capture every inch of water. Is that important? Yes. Absolutely. Now here is some colored water. And we're going to make it rain. We're going to create a miniature rain simulator, okay? We did. And we got holes in the bottom. Can you see it, ladies? The holes? Okay? And this is, I collected disturbed soil. So I took it out of its context, crushed it, collected the top surface, and I put the same depth. And what we're going to do is you're going to pour, both of you at the same time. Go ahead. Don't worry, it's not beer. It's not Barry's beer drinking. No. Look at Barry's going, oh my God. It's just colored water. So what we're going to do.
What are the managements of these?
Okay, now, I'm sorry, thank you. These are the same. This is the no-till. This is my North Carolina no-till, 40-year no-till. This is the conventional. Okay? The vegetable conventional. Same soil types. The farms are a mile apart from each other. Ready? Now you guys are going to pour at the same time. Let's pour at the same time. We don't want to cheat. Ready? Get set. Pour.
Do you have cheesecloth on the bottom of those?
No. Just regular holes. Just regular drilled holes. Oh my goodness. The no-till. See, when I went through ag school, or in just my own paradigm, I used to think if I till the soil and I make it more fluffy, I'm going to create more air and increase infiltration. How many used to think that way? Come on, everybody should raise their hands. I know, I designed irrigation systems. As soon as they turned the pivot on, they had tilled, the water ran off the field. Why? I took the soil, I crushed it, both of them have been crushed, I put it in the surface. Why does it still allow the water to go through? What do you think it's going on? How about our partners from, what do you think? What's going on, Lou?
Yeah, your question again was?
Why is, I took these two soils, I took them out of their context, I disturbed them, crushed them, put them in there, and the only thing I did was tap the edges. When I get a spoon, I tap the edges on both, don't touch the center, so I don't get preferential flow. Why did the no-till allow, and look at the conventional. Why is the conventional still up on top of the surface?
Because you destroyed it, there's some organic matter to pull it in. So
There is no biotic glues, and it goes down into that macropores and the micropores. Those biotic glues, you cannot see them. They cake the soil. They still intact. They're hydrophobic. They're polysaccharide glues. They're made by the plants, the organisms, and they cake that soil. But the moment you till them, and you keep tilling, they're carbon-based. Organic matter is 58% carbon. It's all about carbon. Those glues are carbon-based. You wake up those bacteria, they'll eat those glues, the soil pore collapses. That's exactly what happens. And guess what? 2008, we paid $1,000 for fertilizer. Jane, what happened to the fertilizer on this farm? It's gone right to the lake. The water never entered. And guess what this gentleman did? He creates his own perpetual drought. So when the rain does come, does he capture everything? No. It's not just enough to have a good, healthy soil. You have to have a cover to stop the kinetic energy and to slow that raindrop coming. That raindrop's coming at 20 miles an hour. And it comes like this. The soil seals, water runs off, and you do not capture the complete water from that soil. Oh, by the way, when I say to you, okay, now here's a question. When I say to you the soil is an aquatic system, subaquatic system, what do I mean by that? The soil is subaquatic. I read this one night, reading soil ecology books, and this brilliant scientist, he said soils are subaquatic. What do I mean, guys? Protozoa are aquatic. Bacteria are aquatic. Bacteria are not floating in the air between the particles. Soils are aquatic. They cannot function without water. They will not function with water. 80% of nutrient cycling, biogeochemical nutrient cycling, is biological. No water, no function. So it's very critical that the water gets in the soil. And you've got to hold every drop, and you don't want it to leave your farm without you capturing that potential energy. Doesn't that make sense, William? Makes a lot of sense. Now, Barry, you ready for your two here? Any questions so far? Everybody, our NRCS employees, because you're going to learn how to do these demos. And you know how powerful these demos are? They're so powerful, people sell their cows, have sold all their tillage machines, and we have districts now that have had, started their own demonstration farms because of the demos. Because we're educating people. We're not pushing programs. We're not pushing money. Yes, ma'am?
So in this area, many people would think about the tile drains and the ones
Yes.
that going down the tile drains. So what would you tell them about?
Ah, beautiful. Do you know those biotic glues increase the cation exchange capacity? They hold on to nutrients more effectively. In fact, if we can get some water here, what we've done is, you can do this, is that you can actually put little nitrate strips And our organic and our no-till soils will actually hold more nutrients than the conventional. Why? Now, we know there's more preferential flow in the no-till. We know that. So how do we stop the leak in no-till systems? How do we do that? Living covers. I want the nutrients in the body of a cytoplasm of a root or the cytoplasm of a bacteria. I don't want nutrients leaking. Oh, by the way, that increased cation exchange capacity of the soil, increased organic matter will hold nutrients more than the conventional. Conventional systems are leaky, but so are no-till systems without the living cover. Nature rarely leaks nutrients in the prairies and the forests. So what do the prairies and forests do? They have living root 24/7. That's why we're talking about covers right at the end of the year. Barry? And I'll show you some more data.
You know, each system leaks differently. This one definitely leaks the surface. It's just going to come over, and then once the water does go in, there's no water holding capacity to keep it from just keep going right on and bleeding right out. There's no cation exchange capacity left, like you said. Now we have broken up the macropores in this scenario, but we still get water infiltration and water holding capacity. And the interesting thing that we've seen time and time again with this demonstration is, at the end of the day, when we go out and when we come back and we leave this still sitting here, this one will ultimately have more water in the bottom because it can't hold on to the water. So it also leaks ultimately more total nutrients in the end out of the soil itself. The soil itself has more water holding capacity to take out some of the, we manage with the macropores. And so that's the rest of the story. That's why today, we spent how many years promoting just no-till? We paid for it 40 acres at a time. We paid $15 an acre for how many years? For years and years and years, promoting just the cessation of tillage, essentially. And it's only in the last 5 to 8 years that we've really comprehended truly and packaged up a system of practices that converts land that just wasn't tilled to a quality functioning no-till system that promotes improved soil health and soil function. And so, you know, when Ray does his demonstrations here, not that I would question Ray's integrity or anything, but I really don't know what he did with these soils before he got here. I'm a farmer out there from playing devil's advocate. I don't know what he did with all this stuff. So often, especially with our class, and I don't know if we'll get to do it as dry as it is, but we're going to try this week to show how to set up these tests. These are actual soil profiles cut directly from fields under their current management system in the state that they are. We just take these stainless steel cutters, put them right down in the soil. There's no bottom to them. There's no bottom to them at all. So what we measure with this demonstration, what we observe is we're once again going to simulate rainfall, but we're going to see how do these soils in more of a natural state, taken straight from the field, how do they manage that water? How much water goes in? How much water runs off? And if it does run off, what's the condition of that water? What's the condition of the water once it goes into the bottom pan, if it goes into the bottom pan? So where's my, continue on, Michelle? Who else we got? Let's get somebody together. Come on back. Yeah, come on. Now, it's not an advertisement for any particular company, but it is just an X amount of water. And what we're going to do is we're going to pour these right up here. These are actually rainfall simulators. You all know that rainfall falling from the sky falls at a faster rate than this, but this does replicate a somewhat intense rainfall, which I don't know, I've observed this for many years. When we start out the year with a drought like this, if we get those mid-summer rains, they're probably going to come hard, fast, and then shut off for a second. So we need a system that can manage and capture water from a very intense short-term rainfall if we're going to get any benefit from that rainfall, and if we're not going to lose some of that, all of that soil to the Mississippi River or wherever. So go ahead on 3 and just pour them in there and start the rainstorm. What we have on this side is not really even conventional tillage. We would call it conservation tillage, probably in our standards and specifications. It's a system. Both of these have dried out considerably. This is a long-term no-till. It has had some cover crops on it. And so we've pulled these right out of the existing soil conditions. I've actually ran this experiment this is about the 5th run on this set of soil because it's so dry out there I couldn't get any new ones this time. So these have been run several times. However, exactly the same soil type. These are both Miami soils from one's on my farm, one's on the neighbor's farm next to me. And so what we're looking at is the total function of these soils, even after 4 or 5 replications. The long-term no-till already has some water coming through into the bottom. So we're getting some of that intense rainfall to go into the soil profile. Some did run off. I've done this enough times that even in the no-till, I've got some crusting happening here at the soil surface. The earthworms have actually been in there. They're still alive in there. They've worked. And they've actually kind of sealed the soil surface and taken a lot of my residue. We had to actually replace that and get very much good out of that from this point forward. Once the tillage is done, the crop is growing, and we're into the summer months. If we get that hard rain, you see where it's going to wind up in this situation. Okay? So as we look at this, we ask the farmers, well, forget the system, forget the management. You want water in the summer. If the rain comes in the summer, which of these would you rather have happen on your farm? And most would pick this one because most know how important that rainfall is to get in the soil profile. We take that to a bigger landscape scale. We have to ask ourselves, we've got a lot of farmers, and we've seen on the news the last few years the flooding damages that take place downstream in the Mississippi River. What if on a broad scale, across the Corn Belt, this was the condition of our soil resource? What if it could, out of every one of those intense rainfalls when they come, what if we could store an extra ½ inch of water? Just a ½ inch of water across the Corn Belt. That would be a savings, a storage of the amount of water pouring over Niagara Falls in 85 days or something like that. It's a huge amount of water we can actually store on the landscape where now it has an ability to benefit us, benefit crop production. It's going to cycle through the water cycle so much better. It's going to lead to so much less economic damage downstream from flooding and wind cycles. Okay? So, on a broad scale, what if we could accomplish a healthy functioning soil? That's why we're motivated to try to see if we can make this happen on a broad scale across the landscape. It's going to help the local farmer ultimately get through really difficult drought times like we're dealing today. It's going to help society as well. So that's kind of what we want to bring home a little bit.
Hey Barry, you want to hold this camera? Okay, here's a little, how about our grazing systems? That's another thing. I was just focusing on cropping systems. How about our grazing systems? One of our Pennsylvania grazing specialists, he has a good grazing, I'm going to show you 2 chunks of soil collect with a shovel. And Eileen, our soil physicist from Purdue, she keeps me in order. She said, well, Ray, Dave, you got to make sure, and she gets out the tape measure, and we shave a little bit, make sure they're the same. This is a good measure. This is a demonstration, okay? I'm glad we have her here. Okay, so this is properly grazed, and this is improperly grazed, overgrazed, okay? Now, Travis, we're going to come up here and come and put this up on our scale. And we're gonna turn the scale on. Okay, now let me ask you a question here. You're a good NRCS employee. is which soil is going to weigh more. Let's just say they're very close to the same size, and they are. I did as close as I can get. Which one's going to weigh more and which one's going to weigh less? And you tell me why. Is that a tough question? Okay, what do you think? That's going to weigh more. Travis, tell the audience why do you think it's going to weigh more? He pointed to this is the overgrazed. I want you to look at that. Now you can still see the properly grazed one, but the better grazed one has more vegetation on the top, right? Okay, now go ahead and drop them on the scale and let's test your hypothesis. Oh, can you say why? Yes, tell why. Well, that's science. That's the power of science. It's okay to make mistakes and then you go retest it again. Why? What do you think happened to the pore space? Very good. Why? I'm like a little kid. Why?
Because it's been overgrazed. Doesn't have the root system.
Well, let's test this. Let's test out what he comes up with. He weighs it, and it weighs how much? 6 pounds and 19 ounces. Okay. Now let's do the other one.
You did test this first, right?
Yeah. 5 pounds and weighs less. Yay, he was right. So what happened to it? What happened to the pore space? It got diminished. Does that 20% make a huge difference in bulk density? Huge, right, Eileen? It's huge for when it comes to capturing water. That's what you show a dysfunctional soil. And we're doing that on our cropping systems, but we're doing it on our grazing systems. When I go all over the country, guess what I see? Overgrazed land, and the water runs off. And can you wonder why our water cycle is diminished? Is it possible we're having these incredible climatic things, and I can't prove this, that we're having huge fluxes and change of climate because maybe the water cycle's not functioning, the land's not cooling off, the water's not entering the soil. The water cycle's not complete until the water enters into the soil, not run off the soil. Our job as NRCS, all of us, is to make the soil function. We get the soil right, we get the plant right, we get the animal right, and we get better nutrition. Everything works. And somebody says, well, Ray, you can't prove that. Oh, yes, we can. The literature's out there. And we'll show that later. You guys can go ahead and sit down right there. Now we're ready to do our little, I hope. Okay, now we're going to switch, Barry. We're going to take off your little video cam here. Now, I got me a little toy. My wife let me buy a little toy. It's called a zip scope. Okay, Barry's going to help me here. Okay, this little scope you can buy at Amazon.com. It's made by the company called Aven, A-V-E-N, very cool. And what we're going to do is we're going to sit and look. This is live. What I love about this software, you can take pictures and you can also make little video clips. Very cool. I want you to notice, what is that? A very desiccated worm.
Give him some water.
It needs water. Oh yes, this aquatic environment, worms like moist conditions. They prefer moist conditions. Now look at that poor thing, it's about ready to die. See how it, and then look at this. This came from a, you know what this is? Oh yeah, look at that, isn't that exciting? That's a nodule from a soybean. Mike, do you think it's going to be pink inside? If it's working, isn't it? Let's bust it open and see. Oop. Ooh, stuck to me. There's the nodule. I think I smashed it too much, but yesterday I did it and it was pink. But I want you to notice, look at the nodules on that. Okay. Yeah, cut one, would you? Let's get one. Cut it right there. There's no one there. Right next to my one. Ah, beautiful. Thank you. Thank you. I knew Barry was good to keep around. Okay, let's take a look. Oop. There it is. The pink is showing that the organisms are fixing the rhizobial bacterium. And when we go out there in the field, you got to squeeze those and see they're pink in color. So to make sure that they're nodulating. Anything else you want to add to that?
They're oxygen driven, they're an aerobic bacteria.
Yeah.
They don't function if you seal off the surface and you seal off any of the, take away the oxygen availability, they won't be able to function to their fullest level. They're extremely important to a legume, to a soybean. That's how they get their nitrogen. That's the preferred method of how they get their nitrogen. Soybeans need a lot of nitrogen. Fortunately, they have this symbiotic relationship with the rhizobium that helps them get that nitrogen that they need. But that bacteria needs the good environment to fully develop and complete that symbiotic relationship.
So legumes do not do well in compacted environments. They got to have a lot of oxygen, like Barry talked about. So that's very critical to understand that these legumes need lots and lots of oxygen. Look at the root. These are the root hairs. So we wanted just to show you, now in a good, when there's moisture, you can see all the little critters. And on this situation, it's so dry, we can't see the springtails, you can't see the other little critters in there. But I just wanted to show you what you can do with a little, it's called a zip scope. They call it zip scope. So as soon as I bought it, I was spending a bunch of time out in the garden. My wife was wondering where I was. There we go.
How much did it cost?
75 bucks. And it comes with software and everything. It's a great little scope.
Some of those root hairs that look like root hairs,
Yeah.
I don't know if we can tell for sure. A lot of the root hairs, the corn is very, very dependent and very aided. Same symbiotic, a similar symbiotic relationship that we were talking about for the soybeans, except they benefit greatly from the arbuscular mycorrhiza fungus. Okay, and what that does is it goes in, what Ray was talking about earlier, it actually attaches and goes into the plant root, and in exchange for the sugars from the plant, provides a lot of extra access to water and nutrients and minerals. And so a really healthy functioning system, we really want that beneficial fungus as well. And even in these ultra dry conditions that we've got here, you're not going to get to see it at the pits, and we wanted to bring one with you. Probably much to Rodney's dismay, we're pulling his corn out of his fields already and bringing it in. I told him, hey Rodney, the harvest has begun. But almost zero measurable rain since this was even planted, and this plant still has some health. It still has a real chance at making some yield. But the main reason that it is because if you come up afterwards, I want you to come and look at how these roots have found their way down through some of the earthworm channels, multiple roots following the same path. They also had access due to the long-term no-till and continuous, and some cover crops, some manure on a rotational basis. We have a really diverse population and a good population of the mycorrhiza out there that is helping this plant get access to water that it otherwise would not be able to. The other thing that's helping it is all these roots are finding these macropores and can go much, much deeper, much, much faster than they would otherwise get to. Otherwise, we would have a problem. If this was just a no-till field, it didn't also have high soil health, I can assure you this corn stalk would not have near the soil health that it appears to have here in open air. Okay? So we have given this a resilience against drought that it was not otherwise going to have if it was a not as well-functioning no-till system.
Okay. Remember I told you that you've got the nitrate strips? You asked a question, it was Jane was asked a question. How about no-till and you've got all the drain tile and what's going to happen, right? Jane? I want you to look at this. This is a little nitrate strip from Hack. You buy them, they're not too expensive. On the top they have a key. It's nitrate and nitrite. Okay? Now I want you to read the no-till. What do you think it shoots for? 10. How about the conventional? Yep. Yeah, you tell me what you think. Yeah. Simple little demonstration of the nitrate strips. Okay, so tell the conventional, the no-till leaked how much?
The no-till one is 10 parts per milligram.
Yeah.
This one seems to be the 50.
Mm-hmm.
So this was from what came through.
Yeah. Well, we just poured. What I did is I put the strips right in there, let it all soak through, and I just dropped them in. Now, you have to be careful when you do this demo. Because if you crush the soil continuously, what are you simulating? Tillage. So you're going to mineralize more. So, but the cool thing about it, we've done this consistently, the no-till will actually hold more nutrients than the conventional. We've seen that consistently happen. Now, but you got to be careful again, when you put them in the jars and you keep crushing them, you're going to mineralize it. Now, we've done this, Mark Scarpetti's done it with phosphorus. He's done this one with phosphorus. Same things result with the living cover. The living cover helped hold some of that phosphorus in. Should we give them a break?
Yeah, are we about done with the demo?
We're done with the demos.
I've got a question.
Yes.
Will it pull more nitrogen, since there's not as much water in there, will it pull more nitrogen through the first time? Have you done the test whenever the water's came through?
Oh, and do it again?
Yeah. Is it still the same?
You know what I do is I put new soil every time, so I haven't done that, so I can't answer you correctly. So I haven't done that.
Yeah, like at the end of the day, they can do the
I
I
haven't-
didn't know if it'd be more concentrated since there's not as much water in there, like the first step through or not.
Good thing.
Might be. Let's check it again at the end.
Yeah, we can do it
There is
again.
a constant.
We got a couple of days, we can do it again.
There is.
Yes, ma'am.
We've done it mostly at the end of the day. We kind of
Yes, no-till
jumped
cover.
ship here.
Yes, thank you. Eileen wanted me to make the mention that's no-till and a cover. I'm sorry, Barry.
Well, one thing to mention, we haven't tested these soils, but if you were going to test these soils, what would you predict? Which soil would you predict, based on the organic matter levels we were talking about, which of these soils should have the highest soil nitrate currently in them? Or soil, let's say total soil nitrogen. Which of these two should have, just based on the organic matter conversation that Ray had, which should have the highest nitrogen in the soil?
No-till.
Well, there should
And
be
larger
more-
microbial biomass.
There should be more nitrogen potentially there to leach. However, we'll see at the end of the day. Let's let the concentration issue, let's get it down and see how much comes out the bottom, so we've at least got the same amount of water at the bottom.
Because we've allowed them to go all the way through,
It's a concentration.
same thing happens.
Because I'm going to predict you'll still have a difference at the end of the day. So we will, that's a very good catch on that.
I had a question.
Yes, sir.
About your nitrate test strips.
Yes, sir.
Is that nitrate nitrogen or just nitrate?
It's
That can be a bit,
it's nitrate.
it's nitrate. So you
Yes.
gotta divide that.
No,
by
nitrate, nitrogen.
Nitrate, nitrogen.
Yes. Yes. So that's what the strips, yes, yes, sir.
How do applications of fungicides, and pesticides, and herbicides affect all this biology and the living structure in the soil?
Somebody pay you. Very good thought process. It does impact them. Fungicides hurt the mycorrhizae. They hurt the saprophytic fungus. The saprophytic fungus is what actually helps the decomposition process. They do impact it. See, a lot of people don't realize a lot of our herbicides and our insecticides are not host specific. So they kill a lot of the other stuff too. So that's why we're saying be very careful with your tools. Your tools should be used as an exception, not the rule. Good thought process.
As we pursue high soil health systems, we find that most of the farming operations like the one we're on today, while they're a no-till system, they're probably not going to do completely without chemicals and herbicides because they're in a no-till system. They have significantly reduced the amount of soil pesticides that they're using, and part of that is they're allowing nature to help balance the pests versus the beneficial organisms that live in the soil. And it's hard, it's really easy to just call and have the truck come and get it sprayed to stop a pest issue. But after years of experience, you'll see a lot of these seasoned farmers that have this system kind of figured out. They will resist that urge to spray immediately, let nature work just a little bit to see if it will correct itself. A lot of times, especially like soybean aphids and some of those things, we absolutely can let nature fix that if we'll give it enough time.
Yeah. They're self-regulating, self-healing systems if you let it get away. Let me go about 10 slides and then we'll take a break. 10 slides and we'll take a break. And so I can get on with the system and we'll ask more questions. Go ahead and turn the light off. Okay. Okay, this is the keys to the soil health kingdom. This is the principles that I talk about that apply to me, the most important principles if we're going to get our soils healthy. The first one is context. 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 I'm big on context. We need to understand our ecological context. We need to understand the economic context of the landowner. It's all about context. The soil ecosystem is the integrator. Just because you don't see the prairie and the forest on that soil doesn't mean it doesn't want to function the same way. It prefers to be covered 24/7. It doesn't want to be tilled. Those are things we need to understand our context. It's all about context. When I work with my farmer out there, if I have the right paradigm, the ecological context is that I want to emulate nature, I want to follow her, capture all her synergies and maximize on them, I need to understand my context. And I need to understand the landowner's context. Economically, socially, it's about context. The other one is protect the soil habitat. I am convinced, unless you treat the soil like a living ecosystem and a habitat, we will never fix our resource issues. I am personally convinced we cannot treat our soil like dirt. It is not dirt. It's a living ecosystem. And it's connected with everything else. And the last one is simple. Food. Diverse food. Food, 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 food. And it prefers the living plant. When it leaks all the exudates, all the diffusiates, all the organic matter, it wants compost. If you really think about what compost and manure is, digested plant. It went through somebody's gut. It wants that. It demands carbon. It's about carbon. These are the keys of the kingdom of soil health. If we understand those basic 3 principles, the only reason I keep it down to 3, because our mind won't remember more than 3. The human mind. So I used to think, oh my goodness, the Green Revolution. I bought into the Green Revolution. I have 2.3 billion reasons why I don't believe in the Green Revolution anymore. It's called China and India. They want to drive Buicks. They want to drive Cadillacs. They want to eat steak. They want to eat beef. And you cannot have infinite growth in a finite world. Sorry, it's not going to happen. Notice how the price of oil dropped. Do you know why the price of oil dropped? Because the economy engine has slowed down. The demand of oil. If the sheep burps, oil goes up. Folks, the demand of energy is huge. Let me give you the perspective, just to give you a perspective of how much energy we use. Do you remember those 90 days of oil leaking out in the Gulf? Remember that? That was 4 hours worth what this country uses. This country, by the end of today, will use 22 million barrels of oil. They will be gone. The world uses 85 million barrels. Why am I bringing oil? Healthy soils save oil. It's connected. That's why I love quantum physics and ecology. It's all connected. Do you know why the billionaires, who's that billionaire that's getting into soil health big time? Barry?
Howard Buffett.
Howard Buffett. He calls it the Brown Revolution. He's all about that. Our agency, our chief, is all about the Brown Revolution. He knows if we fix our soil, we got a healthy plant. We got a healthy plant, we got a healthy animal. We have a healthy watershed. It's connected. But the biggest thing we have is this roadblock. It's the human mind. I am personally convinced it's the human mind. I learned in the Peace Corps. The Peace Corps taught us, do not give anything for free. They told us, when you go and you teach conservation, you charge, you give it value. But what they told us also is the old Chinese proverb, if you give a man a fish, you feed him for one day, right? But if you teach them, if you teach him and give him understanding, you feed him for a lifetime. If we teach our landowners, if we work together, because Rodney is teaching us too, it's together. We can pass it, like Ken said, to the next generation, and to the next generation, and to the next generation. That's what it's about. That's what soil health is ultimately about. It's about understanding how the soil ecosystem works. How many of you, now, NRCS employees, this is your first assignment. I want you to go into the website called TED. Write it down, TED. There's a book on biomimicry by Janine Banias. Brilliant. She says biomimicry is mimicking the biology, mimicking the ecosystem. She says we should. It's got 3.8 billion years in research and development. I don't know about you guys, but it's beautiful and it's design. And it's got all kinds of answers. She says there's 10 to 30 million species with well-adapted solutions. Let me bring my point here. Biomimicry is conscious emulation of life genius. Why not mimic the prairies and our forests? Look at this. She's got 12 ideas. She's got 2 30-minute clips. I bought the book called Biomimicry. I recommend that book. She says, look at the 12 big ideas for biology. Westchester University, the power of shape. They actually use, and I'm going to have to get this PowerPoint and get it a little lighter. I think we need to put more lumen here. You can see the fins of the whale. This university is doing research how they put it onto airplanes, the shape, reduce the fuel usage of the jet by 30% by copying the whale shape of the fin. Quenching thirst. There's 2 bugs, the pill bug, thank you, that's better. The pill, oh, that's even better. Whoa. The pill bug in this type of arthropod in the desert actually captures water through their ectoskeleton. Look at the little BBs on top of it. So it collects the humidity from the water, causes it to aggregate, and the water goes right to the mouth part of the bug. They're using this technology, the Mountain Institute, for building new buildings. So they're using the same type of structure, the same architecture, so that the building captures the humidity from the wall, from the air, and then they pipe it right into the building. Oh my goodness! Using the biology, using nature, mimicking her. She said in her 11th PowerPoint, that's where I got all excited, she says, agriculture, you must grow your fertility. Rodney is growing his fertility when he puts those legumes and those cover crops. When we mimic, she says that we got to do what the buffalo did and those prairies. Mimic nature, build their own fertility. We took animals away from agriculture. We separated them. We shipped 10 million hogs to North Carolina. We shipped the grain. It's not sustainable. Our farmer, our grandparents, we had animals in the ecosystem. Sir Albert Howard used to say, nature never attempts to farm without animals. Long sustainable systems have animals in the soil, in the agro-ecosystems. And mimic our forests. Guess what soil health does? Exactly that. That we're using our living diverse covers. That we put those covers and we stop the leaks at the end of the year. No-till, oh my goodness, when I first heard about no-till, do you know 7 years ago, I didn't even know what no-till was? Oh yeah, I grew up in the West. We till, baby. Till, baby, till. We turned that stuff into talcum powder. I didn't know what no-till was. But when I started researching this and I started learning, you know what no-till is to me? It is the epitome of mimicking nature because it doesn't disturb. Nature does not till itself. Earthworms, the dung beetles, she does the aeration. She does that. That's what we're talking about. High diversity, low disturbance ecosystem. That's what we want our agro-ecosystems to do. In this book, you should write down too, students, agroecology. Dr. Gleesman, Dr. Altieri in Berkeley. We had agroecology universities for a long time. Ready for a break? Okay, let's take a break. I already know him. He's going to like, take him out, take him out. Okay.